Given two or more random variables x, y, and so on, we might have a joint probability distribution. We'll omit the "and" as implied. For example, suppose a vehicle could make x equal to 1, 2, or 3 trips and require 0 or 1 stops. Let the probability of making x trips with y stops be given in the table, where c is some constant. Find c and the probability a vehicle makes exactly 2 trips. Since all possible values of x and y are included in the table, the sum of all the probabilities must be 1. And so we have, and so c is 1/12. Note that a vehicle can make x equals 2 trips with 0 stops, or 1 stop, and so, but these events are mutually exclusive, so we can add the probabilities to get. In general, computing a joint probability will require the values of all the random variables. But if we only know one, we can consider all possibilities of the remaining variables to get the marginal probability mass functions of the variable. If our joint PMF is f of xy, the marginal PMF of x is designated this way. So let's consider a joint probability distribution, and we'll find the marginal probability of y. Since y equals 0 or 1, we can find these probabilities. So the probability that y is 0 is the probability that y is 0 and x could be 1, 2, or 3. And since these are mutually exclusive events, we can break them apart into the individual probabilities, and we find likewise, the probability that y equals 1 is the probability that y is 1 and x is 1, 2, or 3. And again, these are mutually exclusive events, so we can break them apart, and we find. And a useful strategy in life and in learning math is to solve it again. Since y equals 0 and 1 are the only possible outcomes for y, they have to be complementary. So once we find the probability that y is 0 is 0.6, we could compute the probability that y equals 1 as, which is consistent with our first solution. Now, we might get our probability mass function as a function, and so let's find the marginal PMF of x. So again, note that x could be 0, 1, 2, or 3, so we compute each probability over all possible values of y. So the probability that x is 0, well, y could either be 0 or 1, and we find the probability x equals 1 is, for x equals 2, and for x equals 3. Remember, no computer ever got fired for making a mistake. Trust, but verify. Since there are many possible values of x, it's harder to find the probabilities using complements. But since these are all possibilities for x, the probability should add to 1. So let's add them up and verify that they do, in fact, add to 1.